So at events like this, we tend to talk a lot about architecture, right? I've attended quite a few talks. We talk about distributed systems, coupling, various things. So we know what, or we think we know what architecture is about, but in reality, architecture is a bit of a funny animal, right? You ask 3 different people what architecture is, and you get probably 3 different answers. Now, I want to talk about architects, supposedly the people doing architecture, and it turns out architects can also be a little bit of funny animals. So what I want to reflect on a little bit is, what does it mean to be an architect? Is it something that's on your business card? Does it mean you make all the decisions? Does it mean you're somehow smarter, wiser, or grayer than the other people, or perhaps not? And I want to start by debunking the first major misconceptions about architects. And that is exactly this idea that the architects are the people who should be making the decisions, who should sort of guide us. They're somehow a little bit wiser or more experienced than the rest of us. I don't think that works very well, right? Because the people who are on the project, the people who actually need to live with the consequences of their decisions, they're probably better equipped to make the decision than some person sitting somewhere over else, where they would go some form of oracle, right? Where they would go, please make the decision for us. I don't think that works very well. That person would have to be A, very, very smart, right? And B, they won't have as much context as the actual team would have. So I don't think that is actually what architects should be doing. But what architects can do instead is help those teams make better decisions, make them a little bit smarter. So my going-in proposition, and if you remember only one thing, this is a good one, so you can leave now, no, don't do that, right? Is that I don't think the architects should strive or pretend to be the smartest people in the room and decide for other people. Rather, we should make everybody else a little bit smarter. And that is actually a very nice thing, because we empower them, we enable them. It also makes us as architects amplifiers, right? We sort of make other people smarter. So in the end, that is a good multiplier effect. And what I'm trying to do today is make you guys a tiny bit smarter, so then you guys can make everybody else a tiny bit smarter. And ultimately, we get a very nice sort of avalanche multiplier effect out of this. Now, the question is, how do architects do that? I don't have a magic recipe, but over the years, I've collected a few techniques and approaches in which I feel that architects can make everyone else a little bit smarter. And the first one is that architects work across different levels. We often wonder, even though we're uncertain what architects even do, the next question comes is, well, who's the most valuable architect? I used to have the title Chief Architect, right? Sounds very ominous, probably should have made me somehow the most valuable, the most important architect. But if all I do is like draw pictures, right, and they don't have anything to do with reality, and sometimes the developers are secretly happy that my pictures don't have anything to do with reality, then that doesn't make me very valuable at all. Right? And then you could make the counter argument is, no, maybe the solution architects or the software architects who like really sit where the rubber meets the road, right? They are more valuable. But on the flip side, if all the great event-driven, asynchronous, loosely coupled thing they're cooking up doesn't ultimately support the business strategy, that is also not valuable. So it's not so easy to say, well, I actually don't even like the idea to judge the value of an architect by their title, their level, or their position. Much rather, my experience is that the value of the architects comes by how many levels can they connect. Because most organizations and teams, folks specialize, right? They need to specialize. Certain people sit at a certain floor of the organization, sort of figuratively speaking, and there's sort of the penthouse, the boardroom where the decision gets made, right? And then there's sort of the engine room where the IT development takes place. And if those are not connected, you have a big problem. And I call this, if the tunnels don't meet, digging faster won't help. And that means that the architects are not the ones doing the digging, but the architects are the ones who make sure that the tunnels meet. So there's this common question about, should architects code? And generally I say yes, because they need to be connected to the reality, to the engine room, coming back to our view of connecting levels, but the main job is not to create code as output. Right? They don't do the digging, but every once in a while picking up the shovel and seeing where the tunnel is going and making sure that the tunnel actually goes to where the other side is drilling from is extremely valuable. Now, you might wonder, why would this happen, right? Don't we have like business analysts and all these things to make sure we have the right requirements and we are well aligned, one of my favorite words, so that things don't go out of whack? The reality is, in large organizations where you have many floors, it's very easy to get this disconnect. This is my classic favorite example. Upper management lives in a happy illusion, right? We have AI and blockchain, so everything must be good. And vice versa, the developers enjoy their freedom because, let's face it, upper management doesn't really understand anyhow what exactly we do, so we have quite a bit of leeway, right? So both sides are happy, but it doesn't make a very effective organization. Now you might wonder, how is this possible? And that is because you have this isolation layer in the middle that's called middle management. They make sure those happy people never talk to those happy people, and they stay nicely detached. We call this a bad case of loose coupling. Right? We would like this to be a little bit more tightly coupled, but you can easily see that this is also delicate, because you might be making each party slightly less happy, but you bring them closer to reality, and ultimately you have a better functioning business, because the developers do things that the company leadership or that supports the business strategy, and vice versa, right? The strategy informs the technology that we use, right? And that's what I call the architect elevator. You might say, oh, if our building has too many floors, can we just take some floors out? And if you hire fancy consultants, they have a word for this. It's called delayering. Sounds really good on paper, very difficult to do in reality. Just like in a building, you just can't take a few floors out. The same is true for organizations. The middle management we like to make so much fun of, they ultimately hold a lot of organizational knowledge, they do other things, so this delayering doesn't work well. So the next best thing you can do is faster vertical movement, right? You put an elevator. Now, I don't think architects have sort of a trademark on being the only people who can make this connection, but I think as architects, you're extremely well equipped to do this. And I'll show more ways in which you can run the elevator very well. Now, I know I wrote a whole book about this, about the metaphor, about being able to understand different objectives and constraints at different levels. And let me just highlight one part. And that is, the elevator is not about telling people at different floors entirely different stories. That's not called architect elevator, that's called lying. Right? That's not what we want to do. We want to connect the dots. We want to translate the decision and the constraints that come out of the engine room. We want to translate that so that makes sense to the upper floors and vice versa. We need to be a connecting element, not tell every party what they would like to hear. And I have many examples where the same bit of information might lead to very different conclusions at different layers. So this is actually a not easy, but very, very important role to play. So one way architects can achieve this is using metaphors. Right? The biggest enemy or the biggest challenge in the architect elevator is the world we work in is very complex. Right? It's like we're dealing with distributed, cloud-based, event-driven, asynchronous, machine learning, right? You name it, right? The stuff we have is globally distributed, transactional, kind of things, all the stuff we're here to learn about, right? It's awesome, but it's complex, right? It's not easy. You can't just go to upper management and say, look, here's sort of my Helm chart kind of thing, and this is why I need funding for Jaeger, for my Kubernetes cluster, for the container. They're going to go like, oh my God, right? So my old joke is always, in the old days, people always complained that IT people, it sounds like Greek to them. Now these days, it actually is Greek because we say Kubernetes and Istio and all the other things. So it became a self-fulfilling prophecy. Now we actually do speak Greek, but it doesn't exactly help the matter. So the question is, or the solution, part of the solution is metaphors help a lot. What metaphors do is they translate your problems, your constraints, your decisions into a different domain that is more easily understood by your audience. So that is very powerful. I'm well known to use a lot of car metaphors. It doesn't matter so much the domain that you pick. The sort of bonus point is if you want to talk to the upper levels of the organization, using the domain of your business, that's sort of the ultimate joker card, right? And I've done this. I worked in financial services. We see an example of this later. So if you can use your own business domain, whether it's financials or manufacturing, right, that is sort of the ultimate A+ grade. But otherwise, any domain that your audience is familiar with works well. So in my case, most people have cars or seen cars somewhere, so I use a lot of car metaphors. I used the naming of this pedal. The US colleagues call this the gas pedal, which is a poor abstraction. We tend to call it the accelerator. It's a much better abstraction. And you see this because electric vehicles have accelerators, don't have gas pedals, right? Leaky abstraction, implementation details leak through. You can start explaining pretty complicated things with simple examples that everybody know. I can talk about disruption and digital transformation with Japanese cars. I can talk about friction. I can talk about platforms from car platforms. And I made fun out of some cloud services of being a halo product, being the shiny car that everybody wants but nobody buys. Right? Everybody sees the NSX, but then they buy the Accord, and the company's happy with that because they make the money over there. And rumor has it, there are some cloud services also like this. Everybody likes them, they're nice and shiny, but the money is made with the Hondas, with the Accords and the Camrys and all the bread and butter services. So very powerful metaphors. Yeah, and somehow, for me, I use a lot of cars, but it works very effectively. And if I run out of steam, so to speak, another metaphor for cars, then I go for trains. So I'm in a good place to make train metaphors. I always explain to people how train wheels stay on track, right? And in this country, everybody should know that. They don't stay on the track because of the flange. They stay on track because of the shape, the tapered shape that the wheels have. So train wheels are self-centering. What does this have to do with IT? A lot. IT governance always talks about guardrails. We need to make sure things don't go off the track. So they want to put a flange, they want to put a limit, but if they forget to make this thing self-centering, that's when the train makes this horrible scraping sound, right, when it hits. So I tell people, whenever you put a limit, you also need to make sure that something helps your device self-center so it will not actually hit the limit. You can also explain this with a car metaphor. I have a common saying, this is, wherever you have a guardrail, you should also have lane assist. Because nobody likes hitting a guardrail. I mean, you're happy you didn't go down the cliff, but your car is wrecked, and they want you to pay for the guardrail too, so you shouldn't be hitting guardrails. You should have lane assist. So these metaphors bring things that we know into an executive audience, and they tend to be relatively sticky. I've taught many people about lane assist, and they run around. It's like, yeah, we need to not just talk about guardrails, we also need to talk about lane assist. And if you're wondering about in the coals and the fire, that is a metaphor for transformation. If a traditional business sees disruptors, sees competitors that are moving faster, launching products faster, like, oh, we want to be like them, the first thing they do is they put more coals on the fire, right, and more pressure on the boiler. And where does this lead? Not to any transformation, it leads to a burst boiler. So I have a saying of, don't burst the boiler, and they understand immediately the fallacy. You cannot compete with a disruptor by pushing harder. You need to work differently, right? You need to replace that steam engine with an electric train or whatever it is. So these metaphors are quite sticky and quite powerful. They're not cute little stories. They're not anecdotes. They're not pure rhetoric. The reason they work is because they allow your audience to think along with you, but in their domain. So you want your audience to come to the same conclusions and understand, right? You want them to understand that hitting guardrails is very inefficient. So they might even come to their own conclusion that, hey, how do we get people from hitting the guardrail? Oh, we give them lane assist. And this is exactly what you wanted. Yeah, in dev speak, this means shifting left, faster feedback cycles, automated controls kind of things, not architecture review boards that tell you at the end of the project that you did everything wrong. That is classic guardrail hitting. So they come to the same conclusion by thinking in the domain of the metaphor. So that allows them to participate in the thought process without having to understand all the nitty-gritty kind of technical things that you're dealing with. And that is, in a good way, that is better resource utilization. Because let's be honest, often when you talk to senior, sort of not so technical people, what they're basically hearing from you is, trust me. Because they can't really understand all the different trade-offs and decisions you made, and they may well trust you, but that's a pretty sort of thin thread to hang on to get support for your project. So if you share metaphors, they can think along with you, come to the same conclusions, and you get a much higher level of buy-in. So metaphors are not just cute stories or pictures or rhetoric. They're actually extremely helpful in this conversation because they invite the other party to think along and come to the same conclusions. Second one that works very, very well and that I do a lot is I say architects see more than other people. And I should say here, footnote, I use architect in a very broad sense. I never believe that it's something that's on your business card. That's why the talk is called Thinking Like an Architect, right? It's a way of thinking. So I want everybody to feel like you can be an architect in this context, right? So one of the things that when I do in my workshops, we have a slide that has 4 boxes and 3 lines. And we talk about this slide for about 20 minutes. So that means other people might see 4 boxes and 3 lines. As architects, we see a lot more. We see layering, we see separation of concerns, we see dependency, we talk about replaceability, we talk about the downsides of excessive layering, of having overhead and change propagation, and we talk and talk and talk, and it's really on the slide, it's like 4 boxes and 3 lines. So as architects, we do see more than other folks, and that's a great thing. It's a great trait of an architect. Often the way this manifests is that we see more dimensions than other people. And that is very useful because folks might have an eternal debate about doing things one way versus the other way. This is one of my favorite sketches where 2 people look at the same thing. The one person says, look, this is a circle. The other person says, well, I have no idea what you're looking at because my thing is a rectangle, and they will never come to a conclusion. Right? This is sort of the classic debate is, oh, should we cut the project timeline? Oh, but we cannot compromise quality. Right? They have 2 things that they feel are opposed, and they will never come to a conclusion. Now, as an architect, you know that these are independent dimensions, so you can talk of things about shifting testing earlier, automated testing. Basically, time and quality are not opposites of each other. You've given people more dimensions. You move this from a one-dimensional space to a two-dimensional space. Now, I used to work for cloud providers, so my proudest achievement, being 4.5 years at AWS, was that I was able to give a talk at reInvent that had the words lock-in in the title, because no vendor likes to talk about lock-in. So being able on stage at a very large event and talking about lock-in made me a little bit proud. So one of the things I did is lock-in is talking about the cost of switching, right? If I want to go to another vendor, can I do this? The answer is most likely yes, but it might cost me more than I want, so I can have this kind of discussion. The first thing I want to do as an architect, say, great, you have switching cost, but what is the utility you get against this, right? You want to use the cloud services, you can build product faster, maybe you can scale more easily, maybe you can make a product that is more competitive. You're also getting something out of this. Because if you didn't, you wouldn't be on this platform in the first place. So now you have a much more balanced discussion. Now it's not the FUD of locked in, oh my God, we're just going to get locked in. It's an ROI. How much am I getting for how much switching costs? And you can start making a formula. How likely is it that we need to switch? How much does this cost? So how much is the overall liability? How much is the benefit against it? Crank the little engine. It's like basically here the answer pops out. So seeing more dimensions is magical in getting these discussions left or right, getting this into a much more productive type of conversation. Now, then I took this further, where I took the switching cost itself down into many different dimensions. You know, people always think the switching cost is I need to switch the vendor. That's what we think about lock-in. But everything has a switching cost. Switching a product, even if it's an open source product, has a switching cost. Even switching from the thing that you build yourself to another version is not free. My favorite example, AWS story again. You guys might know like EKS, Managed Kubernetes Service. One of my least favorite features, I tend to joke, was extended version support. Customers wanted to run older versions of Kubernetes. Of course, we as a vendor always assume you must be on the 3 latest versions, right? Because you're modern, digital, container, cloud-native enterprise, so surely you are on the latest version. Well, it turned out many people were not, and they were happy to pay to get support for the old version because it wasn't free, the feature. Why is that? Because the switching cost between the versions of an open source product wasn't zero. They were locked into a specific Kubernetes version because if they weren't, they would have upgraded. But they're busy with other things. So it might be okay for them to stay on this version, but this lock-in is not something that magically appears between you and the vendor. Any kind of change has a switching cost and has a certain amount of lock-in. So now again, you can have it doesn't mean you all need to agree, right? But you can have a much more nuanced and balanced discussion about this, right? What level of this lock-in is actually adequate? And how come these people aren't on the latest version? Is the switching cost really that high? Can we do something to bring it down, right? You talk much more solution than talking FUD. I'm not going to go through all of these. Maybe the last one is always fun. What is mental lock-in? I always say this is kind of the most subtle but also most sinister version of lock-in, and that is once a company gets you to think in the terms of their product, then you've been mentally locked in. So always make sure you think about architecture in your own terms, not in the little icons and cloud service names, etc. Right? If everything is SQS and SNS and EventBridge, right, it's time to put that aluminum foil hat on and kind of reduce the mental lock-in. You should be thinking about queues and retry policies and the things that actually make your architecture decision. So again, seeing more dimensions, broad things that we would otherwise not see, and this is a way architects make other folks smarter. So I haven't quite been able to get this into a sort of simple framework, but I tried to visualize what some of the key maneuvers are. The one is, can I break this down into multiple pieces? Like, am I making a single decision or can I make multiple decisions? Very powerful. Yeah, people came to me as an enterprise architect, oh, we need to have a standard for API management. I'm like, okay, great. What does this mean? Does this include messaging things, like Rabbit or MQ series or TIBCO? This was a bigger company, so a lot of this stuff is around. How about eventing? Is Kafka in this thing? Is this all middleware? Is this one thing? Is this two things? Is this three things? So breaking down the problem is a very powerful architect maneuver. And once you've done this, you can add dimensions, right? It's not left or right, but I can have both. And then it's also, even though it might be different things, it doesn't mean they're completely independent, right? So you need to understand how tangled up they are. And I found those to be useful models. We call this expanding the solution space. Like instead of one decision, we can make two decisions. Instead of picking left or right, we can pick anywhere in this coordinate system. We made the solution space much larger than we originally thought, and that makes people smarter because there's more stuff up for grabs. They can do things that they didn't think they could have done. Well, I find that to be a very nice thing. You made them smarter and ultimately, hopefully, be a little bit happier. Because let's face this dimensionality, this left or right, is not a happy place, right? If it's like, oh, I can do something quick or I can do it well, you will never be happy, right? Because either you're really slow or you get something really crappy or a little bit of both, right? You'll never be really happy. So getting people out of this one-dimensional left or right actually, I think, ultimately makes them happier. So maybe as architects, we don't make just people smarter. With a little bit of luck, we also make them a tiny bit happier. What architects also do, every once in a while, we have to put our finger in the wound a little bit, like we see more than other people. So one thing that I often see is technical presentations that start with a lot of buzzwords and a lot of promise, then it gets a little wishy-washy and a little bit thin, and then they need, 10 headcount, $1 million, a few externals, hardware budget, come all the demands. And I'm like, how exactly did we get, let me rewind this movie, like how did we get from here to there? It's like a bad academic paper. I'm sure you guys all seen those. It's like survey of the current state of affairs, right? Like 3 pages of all the literature. Then come, a paragraph about your poor experiment, which wasn't actually very conclusive. And then there's 3 pages of future work. Right? It's like every academic has seen those, right? And they quickly get sent back to the sender. I see this in IT all the time. So the middle section is like the skinny one, like, oh, if we don't do this, right, everything will be bad. Everybody does, right? Oh, it's modern architecture. So as architects also, our job is to strengthen the middle part, avoid the hourglass. Get people to think more logically. Is what we're proposing the best way to achieve what we're actually after? What are we really after? Right? People say, oh, we must harmonize our IT infrastructure. Yeah, that sounds good. Like having everything 4 times is probably not good, right? So having something once is maybe better, yes, but what are we really after? We want to reduce our operational cost. Maybe we can achieve that also with automation. So we have 4 systems, maybe not fantastic, but at least they're highly automated, so my cost also goes down, right? So open up the solution space, understand what you're really after, and then pick the one that is best suited, because deduplicating, like harmonizing, also has a cost. If you have 4 of these and you need to make it 1, that isn't going to be free. So as an architect, you give a lot more options. And I call this the architect boomerang. Invariably, people will come to you is, oh, we need to be cloud native because reasons, right? It's like, oh, just everybody does, it's like the way to go, right? And it's like, well, what do we really want to achieve? Do we need resilience? Do we need scalability? Do we need developer productivity? Do we want to reduce switching costs, right? Like, what is it actually that we're after? And then based on that, that's the boomerang, you come back with a better choice. You identify more options, you understand the trade-offs, you can use metaphors to communicate those trade-offs, and then in the end you come most likely to a better decision and better buy-in to the decision. The reason it sort of goes briefly back and then it has to come to a solution is because if you're only backing up, you'll be the architect who's labeled as, oh, this is too academic, we need to make a decision, right? So you back up briefly to understand what we're really after, but then you fast forward from there to actually come to the best fitting option, right? You make the decision, but you have a better understanding why you did this and what you were really after. So I do this quite a lot. A quick backup, expand the solution space, pick something, and move on. Many people have thoughts on how you become a better architect. I offer training workshops, so I should tell you, please attend my training workshops, and many other people have things to sell to you, but my main advice actually is you can learn a lot about architecture from the real world. Like people often say, in order to become a good painter or a good photographer, you first need to become a better seer. You need to look at things differently, right? Because that way you figure out what you want your photo, your painting, your picture to look like. And I think architecture has a lot of similar properties. To become a good architect, you want to look at the world from a slightly different lens. So when I go to the coffee shop, I think about two-phase commit, right? Like basically Starbucks doesn't run two-phase commit. They don't wait for the financial transaction to complete before they start making the coffee. They have a queue, they work asynchronously, their throughput optimized. We can learn a lot from this. And Ian, just before this talk, reminded me, we talked about complex messaging and queuing systems and back pressure, and he said he has observed Starbucks exercising back pressure on the incoming demand by making the cashiers slightly more chatty, because they know they overloaded downstream. Basically, the servers are at capacity. So what you do, rather than piling more things into the queue, you sort of slow the inbound a little bit. Perfect example of back pressure. So you can learn a lot from real life. When I was standing in the supermarket in the queue, I had the insight that in-order message delivery really sucks. I work for a cloud provider, right? And because they're highly scalable systems like EventBridge, et cetera, they don't guarantee in-order message delivery because they have many, many instances running, and some of them will process messages, an older message faster than a newer message, so they get out of order. Every architect would like in-order delivery because things are very convenient. They come out in the same order they come in. Well, the next time you stand at the chain in the supermarket, imagine they were guaranteeing in-order delivery. Right? There's one slow person in front of you, and you're not allowed to pass. Right? Because it's in order. Order must be maintained. That sucks. Right? So think about it. You can learn so much from real world. So I coined a slogan, which is, every architect wants in-order delivery, and everybody waiting in line hates it. Right? So you need to think about throughput versus order. So walk around the world with your eyes open. You don't need to pay for expensive training courses. You will learn a lot because the real world is distributed, asynchronous, out of order, loses messages, has failure. All this stuff happens all around. It needs to scale. It has bottlenecks, right? Try getting into the tube at rush hour, right? So all the things are right there. You can learn so much, and I think it generally makes you a better architect. And bonus, great source of metaphors. Right? You can harvest from the real world. Most of your conversation partners have been in the real world one or another time, right? So using metaphors from coffee shops and trains and congestions and things tend to work pretty well because your audience has actually seen them. So now I want to stretch the metaphor a little bit, or stretch your brains with some different metaphors. I warned that I worked in the financial services industry. So when I'm asked what architects do, and this came out of a real conversation, somebody said, so what do you guys actually do? And I'm not quite sure how it came to me, but it sort of popped out, we sell options. And this was in financial services, so my conversation partners, it was a metaphor obviously, they know well about options. So here's how we buy and sell and trade options. Options are things that you can do in the future, but you don't have to do right now. They're optional, right? It's like a year from now, I have the option to buy this stock, if it's financial people. If you're on a cloud provider, you might like the option to move to another cloud, right? That is an option that you're buying, and when the time comes, you exercise the option. So here, we want to have the option to use different programming languages, right? For whatever reason, people have preferences or have hard proof that using different languages for different parts of the system is the best thing to do. So in order to gain this option, this is a valuable option because if you have these skill sets, right, then if you make everybody do C#, you would have all these developers unused. That wouldn't be good, right? Or they have to be retrained. So the option clearly has some value. Or if you find you have some performance issues, you can switch over to something else. You rewrite this little thing and go, right? The option is undeniably valuable. How do you gain this option? Well, as architects, you all know the answer. It's a more sort of figure of speech is you lock down, you make this in a microservices architecture, and you define a common protocol, right? You say like, okay, everything communicates with either JSON or XML maybe, if you still use like OAuth, HTTPS, right? You lock some things down. So what you've done here, you've traded, you make a trade. You gave up options of the middleware because now you don't have the option to use other things, right? You specified what it is, so you sold some options off, but in return, you gain new options. And I have a book on platform strategy. This is exactly what it plays on. It's called Innovation Through Harmonization. Now, normally we think when we harmonize, standardize, we take choices away. But here it turns out by standardizing and harmonizing, we actually gain more choices. I call this the platform paradox. Like, we didn't actually reduce the solution space, we increased the space by locking a few things down. Well, that is pretty interesting. And this is very much architecture thinking. You can see how these metaphors, right, they're not wordplay or little anecdotes, they really sharpen your thinking. It's, that's like options trading, right? I sell some options, I get some other ones in return. Is this a good trade? Do I want to have this? Now, the nice thing is, so I harmonize here and I gain diversity over there. the nice thing with some of the metaphors, and in this case it works because it's out of the financial industry, is that you're falling back on something that is well known, or at least well known into certain domains. So there's often a big body of knowledge or some prior work, some prior art that deals with these things, and that is the case with options. So the next time somebody asks you if you as an architect bring value, you say, oh, I can prove that to you mathematically. Because as an architect, I can sell options, and here's the proof that options have positive value, and let me know if you have any questions. Now, this is always like showing this chart because it has two purposes. I'm going to go back to the main purpose, but the other purpose is I always like you guys to feel the way it is when your executive audience, right, the folks up in the penthouse, when you show them one of your technical architecture slides. Well, they feel like you looking at this. So it's a good symmetry, right? Because to them, this makes total sense, right? This is like, oh, here's the Kubernetes cluster, here's the Ingress, here's the autoscaler, right? Firecracker, micro VM. We're like, oh, like it's all easy, right? And they're like, whoa, right? So now we get to have this experience. Now, it's not a class on financial management. Folks got a Nobel Prize in economics for this. This is the Black-Scholes formula of options pricing, right? So they say having options is valuable because what options do is I call them the time travel device. Options allow you to defer decisions into the future. Now, why does deferring decisions into the future, why is that valuable? Well, intuitively, it becomes quite clear because in the future, we're smarter. I always say in the future is now, right? Like it's right there. You don't need to project anything anymore. To give you a simple example, server sizing. Right? Capacity planning. Capacity planning sucks because you can only be wrong, right? Either you buy too much hardware, the vendor is happy, but you spend too much money, or vice versa, right? The stuff doesn't run, right? So making these decisions is incredibly hard. Deferring that decision makes this trivially easy to the point that we can auto-scale if you want to. Like nobody even needs to decide by hand anymore. Deferring the decision until runtime is highly valuable. And as architects, we know exactly what this option looks like. It's called scale-out architecture and elastic infrastructure, right? We defer the decision, and that has mathematically proven positive value. Footnote, I say create, normally I say sell options, right? I said earlier we sell options, we don't donate them, and that is because the options aren't free. An architecture that is horizontally scalable needs to deal with state replication, other things. You need high levels of automation to spool up the new instances. You need load balancers, right? Invariably, a scale-out architecture has more moving parts than a single machine, right? So the scaling out isn't free. You're selling the option, so you're making a trade, right? You're paying somewhat in money, but mostly you're paying in complexity. So the price you pay is complexity for this option. So you should decide, do you want to make this trade? Do I want the option to move to another cloud provider? Probably yes, because it has a positive value. Well, here's the price and complexity against it. Is this worth paying for? You once again have a much more meaningful discussion thanks to this kind of metaphor. One thing we can learn from these metaphors is also because I said they fall back on previous insights, and that is the value of an option increases with the uncertainty. And again, that's somewhat intuitive, right? If I can defer a decision into the future, but nothing ever changes, then deferring isn't that meaningful. I might just decide right now, right? It just doesn't happen. So if I build an application for like 2 users, do I need like elastic defer decision? Not really. I just build the thing and I'll be happy ever after. So if architecture sells option, that means that architecture becomes more valuable as the level of uncertainty goes up, because that's when the options that we have for sale, that's when the value of these options increases. The more uncertainty there is, right, the more these options are valuable. It's easy to see. Now, the interesting thing is, we live in very uncertain times, right? A lot of moving parts, pandemics and conflicts and new technologies and changing business models. So the value of these architecture options is actually very high. Now, looping back to the power of metaphors, I promised that earlier that when you have the metaphor, your audience can think along with you and sometimes further than you in the world of the metaphor. So this insight that in an uncertain environment, the value of architecture goes up, didn't actually come from me. That came from my counterpart, who was the head of asset management, who knew a lot about options. He said, oh, I like the idea of options. It's such a great metaphor. And the next thing he said is, oh, the price of options goes up with volatility. We live in a very volatile world. That's why the options are more valuable, and we should invest more in architecture. I'm like, you don't always get this lucky, but sometimes, right, you translate it into the domain of your audience. They can run with this and come to conclusions that you didn't even have, right? That is, every once in a while you get lucky, and that is absolutely awesome. Coming back to the second point. So now we realize the value of architecture is higher if there's high levels of uncertainty. If there's a lot of change in the system, we don't know if this needs to scale and new requirements, different geographies, different functionality, right? Everything is moving. You better have a really good architecture, right? So that is easily understood. Now, a hint on the slide here, and that is there's another popular word starting with A that we use that helps us deal with uncertainty, and that is the word agile, right? Why are we agile? If we know everything and nothing changes, do you need to be very agile? No, you just write it down, you code it out, you deploy it, and you live happily ever after. So that leads to some interesting insight, right? Some of you might have been in a situation, I surely have, where I told people about architecture and an architect, and people say, you know what you architecture people do is really awesome, I highly appreciate it, it's fascinating, but you know what? We're agile. So you do your thing over there, we're fine, we're agile, we don't need any of this. Now you have a very interesting counter-argument. You say, you're agile, great, I like agile. That means you deal with high levels of uncertainty. Like, yeah, it's uncertainty, stuff comes and goes. Like, perfect, me too. So architecture and agility are absolutely no opposites. They're no contradiction. Both thrive with high levels of uncertainty. If I know everything and nothing changes, if I don't need to migrate anywhere, I don't need to port, I don't need to add other systems, I don't need to scale, architecture is very easy. And if I have no functional changes, well, just waterfall is also very easy. Both thrive on uncertainty, so they actually go hand in hand. There is absolutely no opposite, and architecture and agility should like each other much more. And if that isn't convincing enough for your agile friends, he just showed them this, like, look, it's mathematically proven. Any other argument, I rest my case. Coming to the next one, and I stick with our theme of we want to make people smarter. And why do they need to be smarter? They don't need to be smarter in a way like they're not smart enough. They're not dumb, right, obviously. The reason we need to make them smarter is because our world is complex. Right? It's like so many moving parts. Right? Oh, is this more important than this? Like the options. Should we buy the option? Should we not buy the option? How many options we have? Right? This stuff is just complex. The most powerful tool you have for making people smarter so that the mid-levels, right, of the elevator, the top levels, the metaphors work magic. So the mid-levels, you can use the models. Right? That's where you can really get folks to use their brains better. Models are very powerful because we rely on them all the time. You look at the subway map, the tube map, it's a model, right? There's models everywhere. And I borrowed this from Dave Farley, who probably stole this from somewhere else. He has two models of the solar system. Yeah, and this is sort of from the, I think, 1500s, sort of Copernicus, etc., where the Catholic Church was basically arguing that the Earth must be in the center of the universe because God spent so much effort making it, so it's surely in the center, right? So that is a given. Now, unfortunately, whoever creator made this probably didn't read the laws of physics very carefully, because if their little blue dot is in the middle of the solar system, these giant, celestial bodies make some pretty impressive sort of, in Japan we would call this drifting, right? They make some pretty interesting movement that is a little bit unlikely for a thing of this size. So if you have the wrong model, things would seem very complicated, right? The model puts the wrong planet in the center and everything looks really weird, versus if you put the sun in the center, suddenly everything makes sense. So the model really shapes our thinking, and things will appear simpler or more complicated based on how suitable the model is. And I need to catch myself a little bit. I said right and wrong. The models are always wrong. They can be suitable or better suited or less well suited, but they're always wrong, because obviously the solar system isn't this size. It's not actually circles. The Earth is not a tiny little blue dot, and they don't leave sort of red lines behind them. This is wrong on every regard. So models aren't there to accurately depict reality, but they're there to sharpen your thinking, to make you smarter. So architects using models is a great way to make everybody else a little bit smarter. Now I have one ground rule. It didn't quite fit into my list, so it's a bonus one you can take a note, and that is architects are the people who read the rest of the paper. You know, there's everybody throws around like Conway's Law and all metals are useful and big ball of mud, right? Everybody knows all these words, but nobody even read the second paragraph. So architects are the people who read the rest of the paper. So in this case, George Box's famous quote about models, they're all being wrong because they're not reality. The second one is actually more interesting, and that is simple models are the most useful ones, right? Because they abstract away more, versus over elaborate models, right? That is mediocrity. That's the paragraph you should be reading, right? And why are they all wrong? As I said, right? The Earth is not a tiny blue dot on the screen. And the last time I took a hike, I had a really hard time finding the contour lines. Somebody had erased them all. I was totally lost, right? So obviously it is not reality. So that means using read the rest of the paper from George Box is these models that we use a lot in IT, these big tapestries, are actually the least useful models because they don't abstract as much. They're trying to represent reality, but that is not the purpose of the model. The model is supposed to help us make a better decision, not be a depiction of reality. So these tapestries that IT likes to draw are actually not good models. They might be impressive, and I always say, we'll come to this, a good model needs to answer some question. Well, this may answer the question why everything takes so long and costs so much money, but the model doesn't tell us what to do about it, so it's still not very useful. So simple models are more powerful than these over-elaborate, complex models. And that is it's important for us as architects because it's a little bit anticlimactic. When you come with a simple model, you feel like, can it be this simple? And the answer is, if this model lets you make the decision, then that is very, very useful. Now, if you want to make simpler models, the question is, which model do you pick? And we can test this with a system that we all know fairly well. It's called Planet Earth. Most of us have been there at some point or another, and here's 4 different models. Now, the trick question is, which one is the best? Remember, I said the models are not good or bad, right? The trick question is, which one is the best model? The answer is, of course, it depends. Well, smarty pants, right? Can be a consultant, right? It depends, right? But it depends on the question you're looking to answer. We're not making modern art here. We're not making paintings, right? We're driving decisions. We're making people smarter. We want to understand trade-offs, right? So the right model depends on the question that you're looking to answer. And a good model can answer a surprising number of questions. Take the top left one. I made fun of the sort of topic graph with the contour lines, right? The question on the top left can help me decide I want to go for a hike. I don't like steep hills. I want to make a ski resort. I do like steep hills because I want some black runs. I want to build a house outside of the flood zone. I want to build a dam and I see how much water is in. There's many questions this can answer. So the next time somebody says, show me your architecture, you make the mental translation is the real architecture is only in your system. It can be shown. So what can be shown is a model of your architecture, right? So really what they mean is, show me a model. It is a valid retort to say, well, what question are you looking to answer? Because based on your question, I may show you a different model. And if you don't have a question, quite honestly, what is the value of showing the model, right? We're not making artwork. So the right model depends on the question you're looking at. So you want to drive from A to B quickly. You want to build a distribution center. Population density maps do this. Different models for different purposes. And that's the power of models and the power of architects, if you wish, to make these kind of models to answer the questions. So I want a tiny bit, right? If you find the right model, it's a little bit anticlimactic. Things suddenly seem obvious. Like, yeah, we should do this, right? And people feel like, people start self-doubting themselves because as architects, we're sort of supposed to deal with the very complicated and difficult to reverse questions and all this kind of stuff. Like, when you find a suitable model, it seems too easy. You get a little bit suspicious, but that is absolutely correct. The fitting model makes the decision easy, right? You have probably found the right model where things are easy. Important footnote on this. Folks ask me, because I like making custom models, like sketches, drawings, right? Like things that we do as we discuss. So people said, oh, does that mean you don't like standard models like UML or C4? And I said, oh, that's not the case at all. Yeah, Simon Brown, good friend of mine, I like C4. But I find that in my architecture discussions, I don't use it very much. So that made me think, why is that? And I realized the standard models are very good for broadcast communication. Here's the structure of our system. New developer joins your team. They need to have some lay of the land. They read your documentation. They understand the notation. If they don't, many great resources to use, right? For this standard model, it works really well to broadcast a current state of a system to a large audience, right? Everybody can see what it is like. Works extremely well. But to make these custom models, to drive the decisions, you can get more richness out of making your own models, making your own diagrams. So for two-way communication, where the drawing is really a tool to aid the conversation, you're more likely to have custom sketches and custom models. Now in my workshops, these are pictures out of the workshops, what we did is we made a list of the dimensions that a sketch can express. Like the facets, the aspects that a sketch can express. So color, shape, size, proximity, position, right? Containment, labeling, numbering, many, many things. In the end, we came up with over 20 dimensions that a sketch can express. Now that's what makes these sketches, these models so powerful. There was 20 different things that we can use. One of the last ones was the squiggliness. Like basically you can express something by drawing it very neatly or drawing it very loosely. You can express, for example, how certain you are about the decision, right? You can express multiplicity. You make like 3 boxes. Does it mean 3? Does it mean many, right? There's so much expressiveness and richness in there. 20 dimensions we got. So that's why these little sketches, don't underestimate the power of this little sketch. There's an amazing amount of stuff you can express, but you will be able to largely do that only when you have a very specific problem, a specific question you're looking to answer, because otherwise you end up back at the tapestry. So different use cases, different kind of diagrams that you use. So that came to me, that insight. And this is the reasons, right, that we sketch as architects. We're not there sitting with a giant enterprise architecture tool and making these giant tapestries. I find it much more useful to sketch, to make these one-off diagrams. And for really the sketching itself is a tool. We don't use a tool for drawing. We use sketching itself as a tool for us. It's one of my common sayings. I always say, make sure the tool works for you, not the other way around, right? So in this case, drawing is a tool that works for you to help the conversation, help the dialogue, and come to a better decision. One more comment on this, and that is the mistake I see a lot of people make is when they want to talk, remember the elevator, right? If you want to talk to higher level stakeholders, we say, oh, we need a high level diagram. People feel the high level diagram must be very simple. They want to sort of dumb things down if you're a little bit pointed about it. The problem is you're not talking to dumb people. So why would you dumb things down? So the idea that things at the high level are always simple and that at the low level they're always complex, I call this the ultimate arrogance of the software developer. Look, my stuff is so complicated. I need to count all these curly braces, right? And it's like, oh, the damn compiler, right? And all this thing, right? Versus the business people up there, like, oh, yeah, their life is easy. No, it has all the same complexities. They deal with like tax codes and laws in different countries. You know, what is the strategy, expansion, product pipelines, delays. Their world is equally complex. So raising things up is not to dumb it down. You raise the level of abstraction to deepen your thinking at this level. You will see things that you otherwise would not see. So that is very important. It doesn't mean it's trivial or simple or dumbed down. It's just a different level on the scale. One of my favorite examples is a really old movie made by Charles and Ray Eames for IBM back then in the 60s or 70s. It's called The Powers of 10. They basically zoom in and out from like 10 to the 18, like basically all the solar systems and galaxies, and then they zoom into the quarks and subatomic particles. And basically at every level, the thing has a similar complexity. You see the city has a complexity, you see the cell has some complexity, you see the subatomic particles, they have some complexity. The complexity, you see all the galaxies, it has, like the complexity doesn't change with the scale. You're just seeing different things. I think that I found to be a common fallacy, and I want to sort of put my foot down a little bit. Don't do that. Now I have a last part. So now we're super smart, right? We're sort of super brain overpowered architects with all these great models and metaphors and ideas and solar systems and powers of 10, right? So we're going to go conquer the world, right? We're going to go into organizations and listen up, people. I'm going to make everybody else smarter, and you know, the future is here. I can already feel it. Everything is going to be great. That is not exactly the way it normally goes. So there are some failure modes that I wanted to share, and hopefully some tips to get around this. The one failure mode is believing your audience doesn't get it, and then you speak louder or more slowly or repeat the thing that you already said. You're not talking to stupid people. The reason they might not agree with you is because they have different incentives or different motivations than you do. If you talk to senior executives, they mostly care about cost. You try to sell them speed. They might not be interested in speed. They care about cost. So unless you translate speed, you go, oh, we can deploy 100 times a day. And they're like, oh, I need highly skilled developers for this. They're going to cost a lot of money. 20 years ago, they told me client server was going to save me money. Then they told me the cloud was going to save me money. Then they told me big data was going to save me money, right? They're like, every time it costs me more, right? So they're like, I don't think this is a good idea. And he's like, hold on. We can deploy 500 times a day. Right? Because then you can see how this is going. I call this getting a bigger shovel. You're digging a deeper hole for yourself. So you must do the translation. You're talking to smart people, but they have different experiences and different incentive systems. So it's not about repeating one more time what you said, but about understanding what motivates them. You cannot sell speed to people who care about cost unless you can make the translation. And then that's where things like software inventory, cost of delay, opportunity cost, right? So we have some nice vocabulary to do that, but if you don't, you're going to run into trouble. The other thing you're going to want to do as a sort of whippersnapper hyper-architect is you want to change the way people think and work. You want them to be agile, you want them to build, you want them to run experiments, be data-driven, have feedback cycles, right? You want to change their behaviors. You want them to work in tribes and all these kind of things. The problem is it's nearly impossible to change behaviors unless you can change their underlying assumptions that are based on their experiences. Let's say with little clever slogans, this often comes out. Let's say, again, you want to convince your team that you should deploy software more often. If somebody has learned that change brings operational risk, they're not going to like it. It's like, oh, we're going to deploy 100 times a day. They're going to be, this is my worst nightmare. And often they have living proof. Well, imagine, where do slogans like never touch a running system come from? Because somebody did touch it, and they were awake 48 hours over the weekend trying to fix this darn thing. So your great idea of how things could be stand against living proof that they have. So you need to understand the most important question that you should ask yourself is, if people do something that you don't like or that you don't find very productive, they don't want to change so much and they don't like automation and all these kind of things, You shouldn't come to the conclusion that, they may be not the sharpest knife in the drawer and they need to be educated. No, you need to ask, what beliefs must they hold that makes those actions rational? Yeah, if they believe that change is risk, they will be change resistant. And you can talk your mouth silly unless you prove the opposite. You need to go back here. You need to change their beliefs and assumptions. So always think about what belief system they must have to make their actions rational, as opposed to like, oh, they don't get it, right? That's an easy excuse, but it won't get you anywhere. One or two more last ones here is sometimes when you do particularly the boomerang, people say, oh, we just need to make a decision here, right? We don't want to be so academic. I didn't bring a coin, I forgot, but my standard gesture is I take a coin out and I ask them heads or tail. And then they look at me, it's like, oh, what's the problem, heads or tail? It's like, we're going to make a decision. It's going to be a very fair decision, easy to communicate, right? It's like, here's your decision. And then they said, oh, you can't do that, right? And I'm like, oh, you meant we want to make an informed decision. Okay, well, maybe a little bit of this architecture boomerang isn't so bad. Thinking is pretty fast, and thinking has a pretty high ROI. So let's think for a tiny bit, and then we can make a decision which is not actually tossing the coin. And one of the last ones that I have seen is where they feel that we as architects make things more complicated because it could all be so simple. And the way it becomes so simple is very easy. We assume we know the future, nothing changes. Well, life is going to be fantastic for architects, right? We can predict all the needs, we know the scale, nothing ever goes wrong. It's fantastic. I want to live in this world too, but there's one catch. The assumption is wrong. Right? If you're a little bit in mathematics and logic, you know that you can prove anything from a false assumption. Right? So here you have some homework to do. It's like, yeah, I want to live in this world also, right? Just blame reality, but in the end, that is a wrong assumption. So hopefully I gave you some thoughts that architect is not something that's written on your business card. You're not the smartest people. You're not the one who make all the decision, but rather you have some pretty nice tools that you can use to make other people smarter, right? You can use metaphors, you can use models, you can see more dimensions, you connect the different levels, and what you'll find if you do a little bit of here and there, it really makes a big difference. So I hope I made you guys tiny bit smarter so you can make everybody else smarter, and then overall we have a very nice multiplier effect. Thank you very much.